Okay, this should be a quick one. Just wanted to show you an example of why you should always have breakers or fuses or other protective equipment on your devices. What you're looking at is the inside of an Outback Power DC load center with the inverter with its cover exposed on top and the DC load center at the bottom. What had happened was earlier today, one of our 80 amp controllers exhibited a little bit of an issue. Now it's not related to the burn mark you're seeing inside or the melt mark you're seeing inside the load center here. We reset that 80 amp controller. It started MPP sweeping and recovered itself. Before the reset, it wasn't pulling the proper current out of the array that it historically could do. So after we reset the controller, it all appeared fine. And then roughly about 2 or 3 hours later, because we have the Mate 3 tied into Outback's Optics RE site so we can monitor things over a web interface, we noticed that same FlexMax controller dropped out completely. So we immediately came to the battery room, saw that it was no longer communicating with the Outback hub that you see there. The lights were out, and we also noticed that the DC breaker between the battery bank and that particular 80 amp controller was tripped, and it's a 100 amp breaker. So it looks like something happened to the inside of that controller that just catastrophically failed and caused it to trip that breaker. Now subsequently, at the same time, and I'll give you the reason why I don't think these two incidents are related, they just happened again at around the same time, is that we noticed a slight burning smell. Now initially I thought that came from the failed charge controller, seeing that it was able to trip a 100 amp breaker. Now we took the covers off of everything to include, and never mind the exposed wiring, everything's turned off, all the breakers are isolated, and that wiring went to the 80 amp charge controller that has since been removed and is currently being replaced by Outback. We opened up our wiring panel there, just verified everything was good, nothing looked out of the ordinary, and then we popped the cover off our DC load center, off our inverter, and that's when we saw that the main DC shunt, as you can see here, that ties main battery negative into this bus bar up here at the top, that ultimately bolts into that bus bar that serves as your main negative connection into the two 4,000 watt inverter modules at the top. An 8,000 watt Radian inverter, as you see here, is actually made up with two halves. It's two 4,000 watt inverters. But you can see here, and I'll get this in a little bit of a light. Hopefully, there we go. Hopefully you can see that plastic base underneath this shunt is fried. It is melted. You can see the bus bar is severely discolored. It's actually loose. Should not be that loose. That nut is seized in place. It will not come out. It's going to have to be cut off. And you can see this little termination extension, or this little bus bar extension they have on this shunt is actually discolored as well. So this shunt, as you can see, got extremely hot, and there's a picture of the carnage on the backside, as well as what you can see in the back of the load center. You see that nice little charred plastic, kind of looks like molten sugar on the back panel there, but you'll notice nothing else in here is bothered. Everything is fine, everything looks good, all the connections are tight, nothing else got hot except for this one shunt. Now this is what was connected to the other side of the shunt. This is our main battery negative, and don't worry, the DC breaker up there is off. This is isolated. That's why I'm not wearing gloves, but good practice as you should be. Now you'll notice the heat shrink on this connector is all sucked in, which means even this end cable, it didn't get as hot as the bus bar end where this was loose, but it did transfer some of that heat down to the other side of this connection and actually cause this heat shrink to suck in a bit more. So I think what we have here is two unrelated incidents, because it does look like to me that melting has been going on for probably quite some time and just got pronounced enough today, or aggravated today, when that charge controller kept yo-yoing like it was and varying, because we had a lot of cloud cover today as well. So the amount of current with the air conditioners kicking on and off was varying a little bit more than normal. And I think all of that just kind of aggravated this already existing condition. So it looks like, you know, the two are related, but I think we just had a charge controller drop out at the same time again. Luckily enough, we opened up all of our covers just to make sure and spotted this. Now, there were no error messages, no logs, no nothing. We've already spoke to Outback Power about it, and based on some things that the inverter was doing, and I'm not saying that this was the cause of it, it's just being a preventative measure based on what we heard. But based on the activity of hearing some relays chatter there a little bit, they're going to replace that whole control module there on the side. Again, just to eliminate the possibility that may have been related to what caused this. Now, you'll notice there's no blackening of this bus bar here. And again, this has all been discharged and made safe. Now you'll see a little bit, like I said, you'll see kind of like a melted plastic and a little bit char there and there. And I think what happened, and this is my theory, even though this bolt has a lock washer on it and it should not have done this, you'll notice that the lock washer, if I can get it to do it here, it may actually be, okay, it's loose at this time. I'm thinking, just because of the way this sets, it sets in there like this. And this bolts here, this hole in this bus bar bolts to that stud you see there in the negative. I think that was enough to hold us in place. I think this bolt wasn't torqued down enough. I think it loosened up over time, created heat, got a little bit more loose, created more heat, created more heat, created more heat as it started to loosen itself up due to that heating effect. Because if you ever dealt with a soldering iron in electronics, and you'll notice that the ones that have the screw-on tips, you constantly have to keep retightening them because the heat will cause them to loosen up. I think that's what happened here. I think this bolt got a little loose, generated some heat over time, got a little bit more loose and a little bit more loose, generated more and more and more heat, because you can see that is really loose, and that is seized in place. You can't loosen this up anymore. And I think that's what ultimately led to this thing's demise and getting melted the way that it did. So what we're going to do is we're going to have to reuse this bus bar. I'm just going to take a wire wheel to it, clean it up, verify we got a nice solid connection. It is a little bit discolored, but it's looks to be still good. You can't get this bus bar by itself without ordering a whole load center, because this main positive and main negative bus bars in these load centers come with the load center kit itself, and I didn't want to buy a $600 plus enclosure just to get a bus bar. Again, this bus bar looks fine. It's a little bit discolored from the heat, but we're going to take a wire wheel to it. We're going to clean up this mating interface, this mating face that you see here where it connects onto the shunt, and like I said, we'll make sure that it's torqued down properly. Now this shunt piece, because the way these load centers work, it's got this extra piece that comes off the negative, and this is for tying in, you know, other pieces of equipment, whether you got battery monitors, things of that nature. So they do a little bit of a convenience here, give you this extra bar, and you can tie other things into it in order to access that main battery negative. I don't use it in this case. I don't even use this shunt, to be honest with you. The only reason why this shunt is inside this enclosure is that is the way that their bus bar is meant to attach, as you can see there. It's kind of hard to do, kind of hard to get in there and hold the camera, but it mounts the back of the enclosure. This bus bar comes up, and the way it's bent and angled, it mounts into this stud. So my battery cable goes here, their bus bar goes here. And that's really the only reason why it's in there. You could, I guess if you wanted to, mount your main battery negative to that stud and go on about your day, but I'm going to go ahead and replace this shunt just so that it's there in case that we need it, but only this time we'll make sure that is torqued down, and we'll periodically check it. What I'm going to use is this shunt here from Blue Sea Systems DC 500, same 500 amp, 500 millivolt shunt. Again, I don't care about the millivolts of the shunt. I do care that it's 500 amps, but the footprint, if you can see the back of that, is exactly the same as the footprint on Outback's shunt. The only difference is it doesn't have the screw holes on the side of it to screw this extra bar into, but again, we don't use this extra bar, so it'll work in our case. So we're gonna cut this end off of this cable right about this far, about the end of the heat shrink, expose some nice fresh copper, get a new end crimped on it, and then we're going to clean up the back of that, put our new shunt in place just to show you here. And we've already compared the bottom of the two units as far as where that mounting hole and that mounting hole exists. They literally in the exact same spots, so they should work quite nicely. And plus, this is a nice new shunt. The actual Outback one that comes with this extra bar piece and that white piece that you see there, which is nothing more than an insulated standoff, which again we're not going to use. We'll just get that standoff out of there because it is a little bit charred, and again we don't use it. We'll just go ahead and use this one because the actual Outback one was going to have roughly anywhere between a week to 2 week delay, or perhaps even longer to get a hold of. And again, like I said, we don't even use this shunt. It's literally just there to facilitate an electrical connection. So that's where it sits. If anything, it is a lesson in making sure that you periodically do check your equipment, make sure all your connections stay tight, and more absolutely, like in what happened in our case today, when that charge controller popped its 100 amp DC side breaker, which ultimately saved it from doing any further damage. It's just a lesson in making sure that you've got the proper safety equipment where it is needed. And we're going to proceed forward with, like I said, getting this connector replaced and getting that shunt put back in there, and then we're just going to then wait for a new control board to come in and get that control board that ultimately is the brain box for this inverter replaced. Again, Outback is only replacing that controller based on a couple of excessive relay clicking that we heard. It started a few months ago until now, and again, it's not being replaced because they believe it's the cause of what happened to this shunt. It's being replaced because it's the only fault or issue that we could find in the system that led up to this prior. So it's purely being done by a preventive measure. But hats off to Outback. I got him on the phone, very nice. Went through a bunch of troubleshooting steps, very patient. And like I said, this unit, this inverter unit is covered under a 5-year warranty. So you're going to send that board out as a first step. And if we continue to have issues, then they'll continue to dig further. But my opinion is, and as we'll find out as this video progresses on these repairs, I'm going to go with the theory that I think that bolt, again, as you can see there, just loosened up over time, since it's a very loose connection point, and what would have held it in place was just that top bolt there. So it wouldn't have really looked loose even if you were looking at it. I think it just got loose over time, continued to get loose, continued to be a bad connection. Another high resistance connection just generated more and more and more heat until finally it just it started to go into meltdown, as you can see there. But as far as the Flex Max that you see here on the floor, that one that did pop its breaker, we've completely removed it. Obviously, as you can tell from the wiring in the wall, they are also sending a complete replacement to this unit as well. So we'll show you all that when we get it in. So we're going to replace this. We're going to replace that control module inside the inverter. We're going to get that shunt replaced. And then we should be able to bring the solar system back online and continue testing with our replacement 280 amp hour lipo banks. But again, just want to show you, safety is not an option. It is a necessity. Please, please, please make sure that you have all the appropriate breakers and safety equipment in place. Breakers is what saved us today. And had that equipment not been in place, it could have been a lot worse than what you see here. I'll talk to you later. Bye. So you can see we've got our shunt reinstalled, the one we showed earlier. And again, it's a Blue Sea Systems shunt, but it's the same current rating and same milliamps rating that the Outback shunt used. Again, not that we're using this shunt to monitor the current. That's being done external to this because we use the Batrium BMS to manage the battery. Again, we're just using that shunt as the electrical connection point for this setup. That's why we're reinstalling it. And as you can see, again, it just doesn't have that extra bar that comes across the top for additional accessories or additional ways of tying into the main battery negative that would go through the shunt, so you'd be able to read that current. But again, we're not using that bar either, so for us this should work fine. The bar itself, this is what's left of the old shunt. As you can see, we had to hacksaw the old bolt off because that was just seized in place due to heat. But we did get our bus bar off, and as you can see, we've got a nice shiny bus bar again. And you can see that that is a copper bus bar that is coated, because you can see where some of the coating was removed as we were kind of cleaning the bar up, and you can see the copper underneath. And what we used to do that was just one of these high grit 3M rubber or foam sanding blocks. It's the same sanding block we used on our bus bars when earlier video when we were putting our new 280 amp hour battery banks into the main positive negative bus bars, just giving us some nice bright shiny copper before we made the connections. We did the same thing here. We just sanded it very, very lightly just to get off the surface black marks from the plastic and such that had melted. And as you can see, we did that even on that end as well. But we are left with a nice shiny and very much usable bus bar. So we're going to get this installed, and we'll show you what that looks like when that's in. But that will be as far as that we can take it until we get that new control board. Again, that control board is just being replaced due to an unrelated issue with this inverter. But we'll have to unfortunately hold off until we get that replacement charge controller and that replacement board. But we'll bring you all back when that's done and show you the system power up again. And we'll bring you back in a second. And there we go. You can see that we've got our replacement shunt installed, secured. We've got a new connector on that cable in there, our main negative coming in, and we've got it re-secured to the main negative bus bar that feeds the inverters. It's in there, it's secure, it's triple checked, everything to be tightened and torqued to where it needs to be. It looks a heck of a lot better than what it did, let me tell you. I just got the confirmation email for the RMA for the control board for the inverter unit. Again, the control board is not being replaced related to that issue there. It's being replaced just due to some relay chattering that we were hearing earlier on. So we shall see. We'll get when the replacement board comes in, we'll video that, we'll get that in, and then we'll bring you back for powering everything up. And also, we'll get that replacement Flex Max 80 you see here in the floor. Once that one comes in, we'll get that one up there, because like I said, that one did fail, and it did for one reason or another. Trip a 100 amp external breaker, and part of the RMA, because this is under warranty, will be that this has to be shipped back to Outback. So it'll be interesting to see if we can get them to run some diagnostics on that, and tell us why that exactly failed. Maybe they will, maybe they don't. If they can and they do, I'll definitely let you know. But we'll bring you back when we get the rest of bits and pieces in and we're ready for power up again. Talk later.